How's it going, guys? In this video we're going to go over how to identify oxidation versus reduction reactions. First of all, we're just going to go over this kind of really basic mnemonic here that people use for these types of problems. It's oil rig. Oxidation is losing, reduction is gaining, and that essentially just means whether or not you categorize it as oxidation or reduction is contingent upon whether electrons are being lost or gained in that element of that reaction. And then I'm going to get to this little thing here that I like to draw on all these problems if I can, and how that's helpful. So first off, I'm going to start with probably the simplest possible one. Na plus Cl yields NaCl. The good way to start with this one off is, if you have a single element alone and there's no charge specified, assume that it's neutral. So we can put a 0 up there and a 0 up there. What we're doing right now is we're figuring out the oxidation numbers. So then in the final product, we know that these are going to be neutral together, but we have to ask, what are they both bringing to the table? So in this case, we can consult the periodic table, or eventually you'll end up just knowing it, but for Cl right there, since it's in this last column, it's going to be -1. And without even looking, we can know that the Na here has to be +1, but you can also find that that is in the first column, right there under hydrogen, so it's going to be a +1. Now what we're going to do is we're going to compare these numbers. So from here to here, sodium goes from a 0, a neutral charge, to a +1 charge. Now, this is the part that sometimes loses people, basically figuring out the difference between the positives and the negatives. So if the charge increases by 1, electrons are negatively charged, so that means that we have, in this case, lost an electron in order to increase our charge. So in this case, we can write out oil. Oxidation is losing. It loses 1 electron in order to bond with chlorine. So in this case, we can compare chlorine over here goes from a 0 neutral charge to a -1 charge. We know electrons each carry a -1 charge. So in this case, it gains 1 electron. So that is Rig. Reduction is gaining. So in this problem, basically what's going on, sodium is oxidized and chlorine is reduced. So from there, sometimes professors will ask for this, sometimes they won't. You can split the reaction. So for Na, we're gonna write out exactly what's happening for just Na in this reaction. Na goes from neutral to Na +1 plus 1 electron. And chlorine is neutral, but we need to indicate on one side where the electron is. The electron is gained, so we're going to put it on the left. And we're going to end up here with the Cl-. So that's kind of what this diagram here is. I just write this arrow is indicating the yielding sign in a reaction. If the electron comes before, it's going to be reduced, and if it comes after, it's going to be oxidized. So you can kind of use that. I used to use that to like double check my problems. So if I go through and I think for some reason Na is reduced instead of oxidized, I'll check here, and I know that based on where the electron ends, it's on the end. Kind of it leaves, it's shooting out of the element in a way. If it is on the left, then we know that's going to get added into that element. So that's kind of a good way to think about that. And that's probably going to be the last simple one, because whenever there's just 2 elements in the problem, I think that it's pretty straightforward if you can understand these concepts and you know how to split like one of these reactions into these. So let's see, the next one we're going to go with is 3SO2 plus 2HNO3 plus H2O yields 3H2SO4 plus 2NO. So in this problem, one thing that we can kind of look at is, first is the O's. We're kind of going to ignore the subscripts here. For every O, we're going to have just a -2, because again, you can consult the periodic table. And this particular periodic table actually indicates the oxidation state right there, 2-, you can see it. So that's kind of lucky, but yeah, so that's 2-, and then this whole compound here does not have a net charge, so we can assume that it's neutral. That being said, if each oxygen is -2, 2 times 2 is -4, that means this S must be +4 in order to to neutralize this compound here. And then we're just going to keep moving across like that. Over here we have another oxygen. We'll put a 2- there, and we'll figure out what the total net negative charge here is. -2 times 3 is -6. For hydrogens, just like we had in the previous problem with Na, each one is gonna be a +1. We don't have to worry about this because it's doubling this entire compound, so the ratios will stay the same. And then that's kind of what we're after here. So again, we have -6 for that charge there, and then we have over here +1 on the hydrogen. So that means in order to neutralize this, we need that nitrogen in the middle to be a +5, because 5 + 1 is 6, and this here is -6. And then for the O, or the H2O, I'm sorry, each H is +1 and -2 for the O. 2 times 1 is 2, plus 2 minus 2 is 0, neutral. Okay, great. So now we can keep moving to the other side. I find it's easier to just find the oxidation number for every single element in the equation first, and then move from there. So again, we have an O. We're going to put a -2. 2 times 4 is 8, so we have a total of -8 on this side. The hydrogens are going to be a +1, I believe. So we have +1 there. So again, we said we had -8 here, and 2 positives from the hydrogens. So that would mean that this sulfur in the middle has to be a +6 in order to keep this neutral. And then over here, it's just a really straightforward. We have a 2- on the O. N is one of those variable ones, so we can just put a 2+ there, neutralize that. So now, what are we looking for? Say we're going to look for the S and the N. We will compare these. So the S goes here. It goes from a +4 to a +6. So now let's think of the charges again. +4 to +6, we are increasing the charge, which means that we must have lost 2 electrons. So if we lose 2 electrons, oxidation is losing. Sulfur is oxidized. Now we can compare the N. So it goes from a +5 to a +2. So we, in this case, gain 3 electrons. And if we're gaining, it is Rig. So nitrogen in this case is reduced. So that is kind of one of the more complicated ones. We'll take this away and then we'll do the next 2. Oops, that's 3. This one's going to be Br plus SO3 2- yields Br minus plus SO4 2 minus. In this case, some of the charges are actually offered to us, so we can use them exactly as you'd expect. Just like with the very first problem, this Br is alone, so we're just going to assume that that's neutral. Then moving forward, we have the oxygens here have a 2 minus charge each. So that's -2 times 3 is a -6 charge in total offered by that O. But this isn't a neutral one. This is a 2 minus as this compound. This whole compound is charged with the 2 minus, which means instead of taking the sulfur and making that +6, we're only going to make it +4, because the remainder, 4 minus 6, is going to be -2. Or I'm sorry, it's going to be 2, but -6 plus 4 is going to be -2, which is what that charge is there. So that's how we can solve that. When this one's alone and has the negative sign, we just know that that's a -1. And then over here, we're going to do the same thing we did over here. Each oxygen is -2, and it's SO4 instead of SO3. So we have 2 times 4 is 8, -8. And we're going to compare that to this. It's going to have to be a +6, because it's -8 plus 6 equals -2, which is the charge that is on that compound at the end. And now we're just going to go through just like we did previously and compare these. So the Br goes from here to here. It goes from a 0 to a -1, which means it gains 1 electron. If it gains 1 electron, that is Rig. Reduction is gains. Now, for the sulfur there, we're going to go from a +4 to a +6. So in this case, the charge increases. We lose 2 electrons for that sulfur, which means oil. Oxidation is losing. So that one's pretty straightforward. We'll do one more problem on this to wrap these up. In this one, again, I'll split it like we did with the first one just to give some extra practice. Zn plus Cu 2 plus yields Zn 2 plus Cu. This is kind of an odd one because they're not necessarily merging, they're just kind of, it's more of a transfer of electrons, but we can still break it up like we did. This is kind of like a simplified way to look at it. This we can assume is a 0 because it's alone. This is obviously a 2 plus, it's alone, becomes a 2 plus, and this is 0. So for Zn we go from 0 to 2 plus, so it loses 2 electrons, which means that that is oil. And for the Cu, it goes from a 2 plus to a 0, which means it gains 2 electrons, which means that's Rig. So we can split that up into Zn yields Zn 2 plus 2 electrons. Then we have Cu 2 plus 2 electrons yields a neutral Cu. And checking back in with this, we can compare that. Make sure this makes sense. So up here we said that the zinc is oxidized and the copper is reduced. Now down here we can see the electron on the right for zinc, the electron on the right, oxidized. So that's kind of our way of like double checking. Now down here we have the electrons on the left, and down here we have the electron on the left, reduced. That's another way of double checking. All right, great. Hopefully this is helpful. I know this video in particular was requested by one of the commenters. Yeah, I'm going to try to keep this video series going, and let me know if anyone has a particular problem set they'd like me to go over. I'd be happy to do so. Hope this helps.